Okay, the second example that I have for you this time looks at a single body under constant acceleration, and it'll use the two tools that we've developed over the past, I think, two classes. Particularly, we'll be looking in the context of stopping distance. We have a car traveling this way. This meaning this is what I'm considering to be the positive direction. The car is driven by Chris. That was Chris Lacoste 10 years ago, if you're wondering. Approaches a stationary squirrel named Chippy at 35 meters per second. At 80 meters out, Chris slams on the brakes in a bid to save Chippy's life, causing an acceleration of minus 6.7 meters per second squared. Does Chippy live? First, it makes sense that the acceleration is negative. We're indeed looking to hopefully come to a stop before we reach Chippy. Certainly looking to reduce the magnitude of our speed in this direction. And so the direction, if we're traveling in the positive direction, our acceleration needs to oppose that. And so it should have the opposite sign, and it does. Does Chippy live? Well, I kind of said how it makes sense to check for that. We know, given an acceleration of that's opposite sign to our velocity, we're slowing down, we know we're going to come to a stop. And we know Chippy is stationary. So we can simply figure out where will we come to a stop, and if that distance is beyond Chippy, Chippy is dead. If that distance is before Chippy's location, Chippy survives. Now, sometimes the hard part is starting. Right now, the good news is that we really only have two tools for dealing with this type of motion, and we can write them down. We have that the final velocity is equal to initial velocity plus acceleration times time. And secondarily, or other, we have this equation that we just introduced last time and showed where it came from. And that's d equals vit plus 1/2 at squared, the distance covered during an acceleration. In this case, a negative acceleration, but that's no trouble. Now, ultimately, we're looking for the distance d of the covered during this deceleration, because if it's greater than 80, Chippy's dead. If it's less than 80, he's alive. That's the whole check. Now, okay, so maybe we can jump in and solve here. We have initial velocity, 35 meters per second. We have acceleration, minus 6.7. Okay, but we're looking for d, and we don't have time. We don't know the duration of this acceleration, so we're not ready for this. We come over here. Do we have enough information here? I think we do. We have initial velocity and acceleration, as we said. We don't have time. Do we have final velocity? Well, it isn't directly stated, but we're asking how much distance will it take to stop? And the stopped condition is that where your final velocity is 0. Sometimes we'll draw an up arrow like this and a 0 to indicate that that's 0. So we have 0 meters per second equals initial velocity 35 meters per second plus minus 6.7 meters per second squared times t. Now, I'll show my work, even though it might be unnecessary. If I want to solve for t, I'm going to subtract 35, and I get minus 35 equals minus 6.7 t. So that means t is simply equal to, I'm going to divide both sides by minus 6.7, so that's minus 35 over minus 6.7. This is good news that this is negative divided by a negative, and so it's going to come positive. Imagine if the time came negative, you'd know something was up. And that comes to approximately 5.2 seconds. So this is saying that in 5.2 seconds, the car will stop. We'll come over here and find out how far will we have traveled. I'm just going to make a dividing line so that the two solves stay separate. Okay, we get d. This is what we're looking for. Vi, we have 35 meters per second times the time. We've now found that to be 5.2 seconds plus 1/2 times the acceleration. Important to grab the negative sign here. Meters per second squared, okay? And then times 5.2 seconds squared. That's an S for seconds there. And this, you should follow along with a calculator just to make sure that you know what's going on. And that should come to 91.4 meters. And of course, 91.4 meters is greater than 80 meters. And so our Chippy is dead. Very sad.